Welcome to solverfy.
Okay, so we're given this list of number 1, 2, 3, etc., to 2n, where n is odd, right? And the first thing to notice is that if there are two n numbers, 1 to 2n, then you've got n odd numbers, so 1, 3, etc., and then n even numbers, all right? And in this sort of exercise, it's easy to lose track of what we're looking for, or how to approach this thing. And what I propose is to bunch up the numbers into the different groups, into their categories. So you simply bunch up the even numbers together, and you don't care about what happens to them, and the odd numbers together, and then you end up seeing what happens. And so if you bunch up these numbers together and you're indiscriminate about what their value is, but only care about the parity, you actually reduce the number of possibilities in terms of their interaction. And by that I mean, if you have two even numbers and you take the difference between them, you end up with an even number. If you take two odd numbers and you take the difference between two odd numbers, you get an even number. And if you have one of them odd and the other even, then their difference is odd. And actually, these three different cases allow you to solve this question. So let me be more precise. So say you've got these n odd numbers and n even numbers. Three cases, three scenarios. You've got three scenarios. If n, if you pick j and k, if j and k are both even, then j minus k, you take the distance or the absolute value of the difference, j minus k is also even, okay? And so what happens is that if you have n odd numbers and then n even numbers, then in the next step, what happens is that you've got uh, n, you still have n odd numbers, all right? And in terms of the even numbers, you've taken 2 away and you added 1. So that leaves you n minus 1 even numbers, all right? Now, if j and k are odd, then j minus k, so then j minus k is even, and you end up with, so you basically took two odd numbers and you have n minus 2 odd numbers, and you've got n plus 1, and you've added one even number on the blackboard, so you end up with n plus 1 even numbers. And finally, the last scenario, so that's the last case is if one is odd and the other even, then j minus k is odd, and so you took one odd number to make the subtraction, but then you've created another odd number, so you end up with n minus 1 plus 1, which is n odd numbers, so that doesn't change. And in terms of the even numbers, you've taken one away and you haven't created any, so you end up with n minus 1 even numbers. And now the thing to notice is that whatever operation you do, you can only, in terms of the odd numbers, have the same, come back to the same amount of odd numbers, or take two odd numbers away. All right? Another way of saying this is that whatever action you take, if you have, let's say, an even amount of odd numbers, then you will necessarily at the next step also have an even number of odd numbers. But in our case, we start off with n odd numbers, okay? And so whatever the action we take, we will always have an odd number of odd numbers, all right? And then to finalize this, the only thing you have to add is that at each step, you take two numbers away and you create one. So at each step, you basically lose a number. Since you have a finite amount of number in the first place, this process will necessarily lead you to having one number at the end. Okay, so one number remaining. And to show this rigorously, you can say that suppose, for the sake of contradiction, that that number is even, then that implies that there is zero there's zero odd numbers left, but zero is even, which contradicts what we've said, namely that there will always be an odd number of odd numbers if n is odd. Okay, and that finishes the proof. You can write this down slightly more rigorously, but this is basically the main idea behind it. Okay, I hope this helped, and have a good